Hello everybody, welcome into another lesson. Today we are going to talk about functions defined by equations. So I'm sure a lot of you may or may not have seen this notation before. F of x equals x. This is how it's read. The f parentheses x, that's f of x. That's how you would pronounce that, is equal to x. F of x is the same as y. So you can just substitute y for f of x or f of x for y. They're the same thing. This means a function of x. Y is a function of x, so therefore it's f of x. This right here, that's the parent function, y equals x, or f of x equals x. So from here on, get used to seeing the f of x notation. That's the best thing I can suggest, because we'll be working with it quite a bit. Alright, let's say we have the function g of x, because sometimes you'll have other letters too, like g of x, it works the same as f of x. You may have p of x, h of z, so on. It works the same way. Say g of x equals 5x plus 1. So you got the function g of x equals 5x plus 1. They give you the domain is restricted. The domain is restricted to -1, 0, and 1. If we recall from yesterday's lesson, the domain are all the values for the inputs, your x values, that your function can have. They've restricted the domain to just -1, 0, and 1, so that's your domain. You're being tasked with finding the range of this function, which would be the y values, the outputs of it. In order to find the range, to find your outputs, you just put in each value of the domain into this function. So put in 5 times -1. We'll start with the first one. 5 times -1 plus 1. That's equal to -5 plus 1, which equals -4. So we have -4. Then for the next one, put in 0. 5 times 0 plus 1. That's equal to 0 plus 1, which would equal 1. So far we have -4 and 1. And then put in positive 1. 5 times 1 plus 1. That's going to be equal to 5 plus 1, which is equal to 6. So for our outputs, the y values, or the g of x values, we have -4, 1, and 6. So your range, listed as capital R, is going to be -4, 1, and 6. That would be your range, would be -4, 1, and 6. Alright. Let's see here. We have one where f of x is equal to 3x minus 4. So f of x equals 3x minus 4. The particular domain for this function is going to be 1, 2, and 3. So f of x equals 3x minus 4. The particular domain for this one is 1, 2, and 3. Normally it's a set of all real numbers, but in this particular time they only want the domain to be 1, 2, and 3. That's it. So again, we have the domain. We're being tasked with finding the range of this function. Well, you're going to take each value of the domain. We'll start with 1. You put that in for your x value in the equation. So 3 times 1 minus 4, well, that's equal to 3 minus 4, which is equal to -1. So we got the first value of -1. Next, you'll take your domain value of 2, put that in for the x, so you'll have 3 times 2 minus 4. That's equal to 6 minus 4, which therefore is equal to 2. And then last but not least, you take your domain value of 3, put that in for x, so you'll have 3 times 3 minus 4. That's equal to 9 minus 4, which therefore equals 5. So we have the range values of -1, 2, and 5. So the range of this function is going to be -1, 2, and 5. That would be your range, -1, 2, and 5. Okay. How about this time capital G, because sometimes you'll see a capital letter too. You have G of A, which is another way of having f of x, but in this case it's G of A equals 4a to the second minus 1. So G of A equals 4a to the second minus 1. Your domain is going to be -1, 0, and 1. That is for your domain of this function is going to be -1, 0, and 1. So now we got to find the range. So you just take each value of the domain, put it in for your A. You'll have 4 times -1 to the second minus 1, which is going to be equal to 4. Well, times -1 to the second is just 1. That'd be 4 minus 1. That would give you 3. Now, put in 0 from your domain. You'll have 4 times 0 to the second minus 1, which is equal to, well, 0 to the second is 0. 4 times 0 is 0. You just get -1. So you have 3 and -1 so far. Now you'll put in that 1 value for your A. So 4 times 1 to the second minus 1. Well, 1 to the second is 1, times 4 is 4, so that'd be 4 minus 1, which equals 3. So you have 3, -1, and 3 for your range. If you have 2 repeating values, you only got to list it once. You only need to list it once. You don't have to list it twice. So your range, and it's best to go in order, is from -1 to 3. You want to go in numerical order. So your range is only -1 and 3. That's it. All right. This time we have Q of C is equal to C to the third plus C to the second plus 3C. So Q of C is equal to C to the third plus C to the second plus 3C. The domain of this one is going to be set to 0, 1, and 3. So the domain of this function is 0, 1, and 3. Again, you got to find the range of this function. So what you're going to do, take each value of the domain, put it in for the C. So you'll put in the 0 to the third plus 0 to the second plus 3 times 0. Well, 0 to the third is 0, plus 0 to the second is 0, plus 3 times 0 is 0. All those come out to 0. So far our first range value is 0. Now take your next domain value of 1, put that in for the c. So you'll have 1 to the third plus 1 to the second plus 3 times 1. Well, we know 1 to the third is 1, plus 1 to the second, that's also 1, plus 3 times 1, that's 3. 1 plus 1 is 2, plus 3 is 5. So now we have another range value of 5. And then last but not least, let's put in 3. So you'll do 3 to the third plus 3 to the second plus 3 times 3. Well, 3 to the third, that's 27, plus 3 to the second, that's 9, plus 3 times 3 is 9, which would give you 45. So your range values are 0, 5, and 45. So that is your range of this function is going to be 0, 5, and 45. And that's it for the range. And I think finding the range of a function is pretty straightforward. Now, had the domain been all real numbers, that would be the answer too for your range, would be all real numbers. Sorry, I had something come up real quick. Okay, now we're going to shift it a little bit. Let's say you have a function like this. F of x equals 5x minus 9. So you got the function f of x equals 5x minus 9. Well, what if they want you to do this? F of 3. Well, you see f of 3 then, or f of any other value. If you have a function, then they want you to evaluate f of 3. That means you're going to evaluate the function when f equals 3. So all you got to do is put the 3 in for that x. You'll have 5 times 3 minus 9, which would be equal to 15 minus 9, which equals 6. So f of 3 equals 6. Pretty straightforward there. Alright, another similar one. P of x equals 4 minus 8x. Let's say they want you to evaluate P of 2. You have P of 2, so that means you put in 2 for where the x value is. You'll have 4 minus 8 times 2, which is equal to 4 minus 16, which would be equal to negative 12. So P of 2 is negative 12. That's the answer you would get. Pretty simple, really. You're just simply, whatever that value is in the parentheses, that's what you're substituting in for x, and then you'll get your answer. K of t equals 3t to the second plus 9. So we have k of t equals 3t to the second plus 9. Let's evaluate k of negative 2. So they want you to evaluate k of negative 2. You're just going to put negative 2 in for that t. So you'll have 3 times negative 2 to the second plus 9, which we know negative 2 to the second is 4, so that'll be 3 times 4 plus 9, which is equal to 12 plus 9, which we know is 21. So k of negative 2 is equal to 21. Alright, r of y equals y to the third plus 8. So we have r of y equals y to the third plus 8. Okay. They want you to evaluate, let's do r of 0. A nice easy one. R of 0, which means all you're going to do is put 0 in for where the y is. So you'd have 0 to the third plus 8. Well, 0 to the third is 0, so you have 0 plus 8 just gives you 8. So r of 0 is equal to 8 in this case. So that's really pretty straightforward. That really is pretty straightforward, honestly, about just putting in a value and evaluating it. That's one of the easiest things you're going to do with a function. Alright? So let's see here. Final segment of this lesson. For the function evaluate f of 0 and find f of x equals 0. Okay. So for the last segment of this lesson, we're going to find f of 0, then we're going to set f of x equal to 0 and find that value. So let's start here with our first function. F of x equals 3x minus 12. So this is the function, f of x equals 3x minus 12. First they want you to find f of 0, so let's go ahead and do just that. F of 0, that just means you're going to put 0 in for the x, so you'll have 3 times 0 minus 12, which we know 3 times 0 is 0, so you have 0 minus 12. That just simply equals negative 12. So f of 0 equals negative 12. So that was pretty easy. Now the other component of this problem is to set f of x equal to 0 and solve that. In order to set f of x equal to 0, f of x equals 0, well, f of x equals 3x minus 12, right? You just take what it is, the 3x minus 12, and set that equal to 0. You'll set 3x minus 12 equal to 0, which we know 3x minus 12, that's the same as 3x equals 12, which x would then equal 4. So the value for, to make f of x equal to 0, that would give you an x value of 4. So ultimately it's a fancy way of solving for x. That's really all it is when you set f of x equal to 0. You just find the value of x that makes the function equal to 0. You just take the value of the function 3x minus 12, set that equal to 0. So really not too bad for that either. It's pretty much stuff we've been doing all along, only come today we got this fancy new notation, the f of x. Don't let that scare you. Alright, let's see. F of x equals 4x plus 7. So we have f of x equals 4x plus 7 for the function itself. First, we need to evaluate f of 0. So let's do just that. F of 0, that means we're going to put in 0 for the x's. So you'll have 4 times 0 plus 7. Well, 4 times 0, that's in fact 0. You'll have 0 plus 7, which is equal to 7. So f of 0 equals 7. F of 0, basically, when you do that, when you find f of 0, you're finding the y-intercept. You're finding the y-intercept. You're setting x equal to 0, finding the value of y, which therefore gives you the y-intercept of 0, 7. When we set the whole f of x equal to 0, we're trying to find the x-intercept, which is when y is 0. Well, if we want to find f of x equals 0, we set that 4x plus 7 equal to 0. So 4x plus 7 equals 0, which would have to mean that 4x equals negative 7, then x would equal negative 7/4. So the solution for the f of x equals 0 is x equals negative 7/4. Alright, let's see here. F of x equals negative 1/2 x plus 7. So f of x equals negative 1/2 x plus 7. That's your function. Let's find f of 0 to start. So f of 0, that's equal to negative 1/2 times 0 plus 7. Well, negative 1/2 times 0 is just that. It's 0 plus 7. Well, 0 plus 7, that's 7. So f of 0 is equal to 7 in this case. Now you want to set f of x equal to 0 and solve for x. So you'll take that negative 1/2 x plus 7, you'll set that equal to 0, which is the same as negative 1/2 x equaling negative 7. So then x would equal 14. So you get an x value of 14 when f of x is set equal to 0. All right. Let's see, f of x equals x to the 4th minus x to the 2nd. So f of x equals x to the 4th minus x to the 2nd. First part's going to be easy. We want to solve for f of 0, which means you substitute the zeros in for x, which would give you 0 to the 4th minus 0 to the 2nd. Well, we know 0 to the 4th is 0. Minus 0 to the 2nd is 0. 0 minus 0, that's 0. So f of 0 is equal to 0. Now, we need to take this f of x, set that equal to 0. So you're going to take x to the 4th minus x to the 2nd, set that equal to 0. Well, we can factor out a common x squared, so you'll have x squared times x squared minus 1 set equal to 0. Well, x squared minus 1 factors down into x plus 1 times x minus 1. So now you have x squared times the quantity of x plus 1 times the quantity of x minus 1 equals 0. Set x squared equal to 0. X would equal 0. X plus 1 equals 0, which means that x would equal negative 1. Set x minus 1 equal to 0, which means that x equals 1. So therefore, the solution to this for f of x equals 0, you have three solutions. You have negative 1, 0, and 1. Your three solutions to f of x equals 0 are going to be -1, 0, and 1. It's basically, again, just solving for the function being equal to 0. Alright, 3 more, then we're done. Alright. No, actually, I take that back. We're going to do a few more than that because it's important. How about f of x equals x plus 1 over x minus 2. So f of x equals x plus 1 over x minus 2. Well, we have a fraction. We have a denominator. Well, whenever you have a variable in the denominator, you want to take that denominator, set that equal to 0. X minus 2 equal to 0, x would equal 2. If x equals 2, this whole thing becomes undefined because you would have a 0 in your denominator. So therefore, x cannot equal 2. X definitely does not equal 2. So if we do get a solution of x equals 2 for this, we have to throw it out because it would make the original equation undefined. But first, we're being tasked with finding f of 0. So always first, find any restrictions, like anywhere the function's undefined. Once you do that, you can proceed with the rest of it. So f of 0 is going to be just this. F of 0 equals 0 plus 1 over 0 minus 2, which equals 1 over -2, or simply -1/2. So f of 0 is going to be -1/2. That would be the solution you get for f of 0. Now we're going to find f of x equal to 0. So you take your x plus 1 all over x minus 2, set that equal to 0. Well, we can multiply both sides by x minus 2, get rid of the x minus 2. Now you just have x plus 1 equals 0, which means x equals -1. And it's still defined for x equals -1, so that is a viable solution. X equals -1 for this. All right. F of x equals x squared minus 1 over x squared plus 1. This one might seem a bit tricky at first, because we do have a variable in the denominator. But think of any real number values you put in for x. There is nothing that'll make the denominator undefined, because x squared plus 1 does not factor over the real numbers. There is no real number solution for x. There are imaginary numbers. We'll talk about that in Algebra 2. But remember, the sum of two squares does not factor over the real numbers. So the domain's the set of all real numbers. We don't need to place any restrictions. So we can go right ahead now and find f of 0. F of 0 is equal to 0 squared minus 1 all over 0 squared plus 1. which will be equal to 0 minus 1 over 0 plus 1, which equals negative 1 over 1, or simply negative 1. So f of 0 is simply equal to negative 1. Now, we need to find f of x equal to 0, which means we take the x squared minus 1 over x squared plus 1, set that equal to 0. Well, clearly we can multiply both sides by x squared plus 1 and get rid of the denominator. You're left with x squared minus 1 equals 0. X squared minus 1 factors into x plus 1 times x minus 1. That'll be set equal to 0. So x will equal negative 1 and positive 1. Those would be your solutions for x for setting the equation equal to 0. X would equal negative 1 or positive 1. Alright, let's see here. F of x equals x squared minus 3x plus 2 all over x plus 1. So f of x equals x squared minus 3x plus 2 all over x plus 1. We notice we have a variable in the denominator. We need to take that denominator of x plus 1, set that equal to 0, which would give you a value of x equals negative 1. But if x equals negative 1, you have a 0 in the denominator, which makes the whole thing undefined. So x cannot equal negative 1. That's the only restriction we have to place upon this. If x equals negative 1, it's undefined. And if we get negative 1 as a solution to the equation, we have to throw it out. So once we found our restriction, now we can evaluate f of 0. So f of 0, that's equal to 0 to the second power minus 3 times 0 plus 2 all over 0 plus 1, which we know 0 to the second is 0, minus 3 times 0 is 0, plus 2 all over 0 plus 1, which 0 minus 0 is 0, plus 2, that's 2 all over 1, or just simply 2. So f of 0 is equal to 2. F of 0 is 2. Now, we need to set f of x equal to 0. So we'll take the x squared minus 3x plus 2 all over x plus 1, set that equal to 0. Well, it's clear to see we can multiply both sides by x plus 1 and get rid of the denominator. You're now down to x squared minus 3x plus 2 equals 0. Well, we need to factor that in order to solve it. It would factor down to x minus 1 times x minus 2 equal to 0, which means x equals 1 and x equals 2. So your two solutions to this equation are x equals 1 and 2, which is still defined for that, so we can keep both solutions. So x equals 1 and 2. Alright. Some slightly different stuff here real quick. Let's see here. f of x equals 3x plus 4 g of x equals negative x squared. Alright, so we have f of x equals 3x plus 4 and g of x equals negative x squared. First example here, they want us to find half of g of 6. So we're going to find half of g of 6. Well, how do you do that? So you're going to take 1/2. I would put brackets here, okay? You just keep 1/2 outside the brackets. Now that g of 6, you're just going to take 6 in and put it in for the x. You'll have negative 6 squared. Well, here's the thing. There is no parentheses with a negative sign in the second power. Whenever you just have a negative and something to the second power, it's still negative. So you would have 1/2 times negative 6 to the second. That would be 1/2 times negative 36, which we know would be negative 18. So half of g of 6 is in fact negative 18. And I got more examples here. We have 2 times f of 5. 2 times f of 5. Well, you'll keep the 2 outside of the brackets. 2 goes outside the brackets. Now you just worry about the f of 5, which would be 3 times 5 plus 4, which is going to be equal to 2 times 15 plus 4, which equals 2 times 19, which we know is 38. So this is still largely pretty straightforward. The only thing is you have a coefficient outside of the function you're evaluating. Let's see here. Now, what if we had something like this? F of 1 plus g of 1. So now they want you to evaluate f of 1 plus g of 1. Set yourself up some brackets again, okay? Put your f of 1 inside the first set of brackets, so that'd be 3 times 1 plus 4. That'll go inside your first brackets, plus you'll need your g of 1, which you put in the 1 for x, you would get negative 1 to the second power. Well, 3 times 1 is 3. You'll have 3 plus 4 plus that negative 1 to the second gives you negative 1. So that would give you 7 minus 1, which would equal 6. So f of 1 plus g of 1, therefore, is 6. This time we have f of 2 times g of 2. So we have f of 2 times g of 2. Well, again, get your brackets out here, okay? First worry about the f of 2 in the first bracket. So you'll take 3 times 2 plus 4. That's your first bracket times that g of 2 in the second, which would be negative 2 to the second. Now, 3 times 2, well, that's 6, so you have 6 plus 4. times in your bracket negative 2 to the second, that's negative 4, which 6 plus 4 is 10. So what you're ultimately left with is 10 times negative 4, which would therefore give you negative 40. So f of 2 times g of 2 is equal to negative 40. This pretty much comes down to basic math again. Knowing your order of operations, stuff like that. So, pretty simple stuff. Alright, we're going to change these functions a little bit here, because we have a few final problems, then we're really almost done. F of x equals x squared. G of x equals 2x. So we got f of x equals x squared, g of x equals 2x. Alright. Here's a fun one. Find g of f of 1. Ah! What the heck is this? Okay, no need to panic. G of f of 1. So keep the g outside of your brackets. F of 1, just worry about that x squared equation. Put in the 1 for your x value. So that would be g of 1 squared, which would just end up being g of 1. Now you're down to g of 1. That's not so bad, is it? So g of 1, that's equal to, since g of x is 2x, you put in 2 times 1, which just equals 2. So g of f of 1 is simply 2. Now, in Algebra 2, you will learn about combinations of functions. We basically just did a combination of a function. So there's a little preview of Algebra 2 for you. Wasn't too bad though. Algebra 2 isn't all that bad. Is it harder? Sure, but it's really not all that bad. Now, what if we did f of g of 1? So we do it in reverse, right? We're going to do f of g of 1. Well, keep the f outside of your brackets. Now worry about g of 1 for a minute. G of 1, well, g of x is 2 of x, so that'd be f of 2 times 1. Well, we know f of 2 times 1, that would simply be f of 2. Now we just have to evaluate f of 2, which means f of x is x squared, so we'll put in 2 for the x term. You have 2 to the second, which is 4. So f of g of 1 turns out to be 4. So this proves also it does matter which order you evaluate it in when you're doing combinations. And I think that's all I have for you guys. So that's been it for this lesson. Next lesson we will discuss linear functions. I hope everyone has a good day. Take care.